Okay, the last thing we're going to do is Newton's law of cooling. Okay, the equation I'm going to give you is T of T equals Ts plus To minus Ts times e to the negative kT. Ts is the surrounding temperature. I'm sorry, I should do T of T first. T of T is the end temperature of the object. T sub S is the surrounding temperature, so like room temperature usually. TO is the initial temperature of the object. E is a number, K is the rate of cooling. And that's done in a decimal format. And T is time. And it'll tell you whether it's done in minutes, hours, or whatever it wants. So we're going to look at problem 23. Problem 23 says, a hot bowl of soup is served at a dinner party. It starts to cool according to Newton's law of cooling, so that its temperature at time t is given by, and they give you the equation, which is pretty nice actually. T of t equals 65 plus 145 e to the negative 0.05 t. So A asks, what is the initial temperature of the object? Well, we know that 145 is equal to the initial temperature minus the surrounding temperature. And we don't have the initial temperature, that's what we want. But we do have the surrounding temperature, which was 65, because that's given right here. So then we add 65 to each side, and that would give us T of O equals 210 degrees. So when you take the soup out of the pot, it's 210 degrees Fahrenheit. Part B says, what is the temperature after 10 minutes? So we substitute 10 in to the equation. 65 plus 145 e to the negative 0.05 times 10. So that's here 65 plus 145 times e to the negative 0.05 times 10. And that gives us 152.95 degrees Fahrenheit. So after 10 minutes, it's 152 degrees. And then the last question asks us, after how long will the temperature be 100 degrees Fahrenheit? So we'll say that people won't want to eat it until it's 100 degrees Fahrenheit, so how long will they have to wait? So that's the end temperature, because we want to know how long it will take them to get to 100 degrees. So we say 100 equals 65 plus 145 e to the negative 0.05 t. So you have to isolate the exponential first, so subtract 65. And that gives us 35, I believe. Yep. 35 equals 45 e to the negative 0.05 t. And again, we got to get the e to the whatever by itself, so we divide by 45 to get rid of the 45. And then, in this case, we want to take the ln of both sides, because the ln and the e are going to cancel out. So the ln and the e cancel out. We get ln of 35 over 45 equals negative 0.05 t. And then to finish it out, we divide by negative 0.05 t, or negative 0.05 to get t by itself. So put that in our calculator. Ln 35 divided by 45 divided by negative 0.05. And that gives us 5.02. So T equals 5.02 3. I'm sorry, here it should have been 145. I knew that wasn't right. So you have to divide by 145. So let's try this again. So here I should have written 145. It's going to change it a lot. It shouldn't be 5 minutes. Since it took 10 minutes to get to 152, it wouldn't make sense that it takes 5 minutes to cool down to 100. So let's try it again. ln of 35 divided by 145 instead of 45 divided by negative 0.05. So that makes a little more sense. 28.43 minutes. So after 28 minutes, they can eat the soup.